Hello everyone. In this video we are going to talk about functions in MATLAB, mainly user-defined functions, but there are some other types that we need to talk about. So first of all, what is a function, what's the difference between that and a script, how to use it, and so on. So first thing first, a function is very similar to script, is that it's an M file and it's basically a collection of commands to run some task. But with the difference that function is kind of like its own autonomy. It has its own autonomy, it has its own independence from MATLAB workspace, okay? In that the memory of a function is separate from memory of a workspace. Okay, it can communicate to the workspace, but it does not share its variable with the workspace, and it kind of acts like a black box. You give it some input, it gives you some output, and you do not necessarily need to know what's going on inside. Okay, so it helps your code to be isolated from unintended side effects. We'll talk about that. It is easy to be reused for other tasks. Once you write a function for one task, if in other tasks you need something similar, you can use it over and over, and makes your code modular. Okay, so let's talk about these in detail and see how we can use functions. To create a function, you either go to new and say function, right? Or again, like the past, when you wanted to create a script, you simply say edit. But when you want to start this M file, you don't go with like CLC clear all close all. You start your M file with the keyword function. And you see it's in blue, it's a keyword. This keyword declares your M file to be a function, okay? So that's the difference. Your function must only start with the keyword function. A script can start with anything you want, CLC, close, all, whatever, okay? So that's the first difference between a function and a script. You see here, when I say new function, you see the structure of it, but when I say go new script, you see it's completely blank, which means you write whatever you want. Now, a function, as I said, is like a black box. There is this function, you pass to it some inputs and it gives you what? Some output. So if we draw it, as I said, as a black box, then what you have is this box, correct? And this is a function. This function can have several inputs and several outputs. So let's say it is like you pass to it inputs u and whatever you want, v, and it gives you back outputs maybe a and b. And this function you might show with f or whatever you want to call it, my fun. Okay, so what's happening inside? So how does u and v, how are u and v processed to get you a and b? You don't necessarily need to know what's going on inside, but when you want to write it, you write it like this. You put the outputs inside bracket and combine them. You say these outputs are what your function will return to you, and it is equal to my fun, the name of the function, of what? The input arguments, and you put the input arguments inside parentheses. You say u and v. Okay, so the inputs are combined with separated by comma going inside parentheses. The input arguments, the outputs are separated by comma going inside brackets. Okay, and what's going on here in between? Again, you do not necessarily need to know. The programmer will know more about it than you have to. Okay, what's going on inside? Again, you don't necessarily need to be curious. And you see here the function ends with the keyword end. This end is not always mandatory. You do not need to always end your M file for functions with the keyword end. Sometimes you do, sometimes you don't. When, I'll tell you. If it's a single function like this, you do not need to necessarily use the keyword end, okay? It's a good practice if you do, but if you don't, MATLAB is not going to pick on you. So you see here, this is a simple declaration. You have two outputs and two inputs, and it says the first output is the same as the first input, the second output is the same as second input, but it's not always that simple. Maybe, for example, the first output is sum of the two inputs, and then the second output is the difference between them, right? Or the product, or division, or anything else. So the way you declare it, it's completely up to you. So let's write something first. Let's start with a very simple example and go from there. So let's say I want to write a function that returns to you the distance between 2 points in the space, okay? So if you pass to it x1, y1, z1, x2, y2, and z2, then it returns to you one single output, and that is a distance, right? The distance between the 2 points, the Euclidean distance. So it has one output, and that is called distance, or dist, or whatever you want to call it. Now, when you have one output, should you put that single output in brackets? Again, you can, or you can avoid it. So can I write it like this? Sure. As long as it's one single output, you do not need to put it in brackets. And even if you do, there is no problem. So this is it, and then the inputs are 0.1 and then what? 0.2, where 0.1 and 0.2 are vectors with three components, x, y, and z, and this distance is, as I said, the distance between the 2 points, Euclidean distance, which you can say it is what? Based on what you know, it is equal to the square root of, correct? P1 first component, correct? P1 of 1 minus P2 of 1, correct? That's the x components squared. The difference between the x component squared, or delta x, plus delta y plus what? Delta z, correct? So the second component is y in them, the third component is what? Z. That's one way to do it, right? So you add all of these squares together and take the square root. And what do you want to call it? I would call it my 3D distance, whatever you want to call it. Okay, now we want to save this M file. So I click on save, and unlike M file, when I wrote an M file and I did something in it, right, whatever it was. So let's say if I want to do something similar in an M file, I have to define P1, I have to define P2, and then I have to define the distance, okay? So let's say I provide some numbers for P1, 1x, 2y, 5z, and then here negative 2x, 3y, and 4z. Right? So here, this script does the same job. You define 2 points, any 2 points you want, and then it calculates the distance and return it to you, okay, like that. Now, when I want to save this script, look, when I click on save, it does not really force me to select any name. It just called it untitled. But can I call it anything else? Sure, I can call it whatever I want. I can call it test 1, right? Is that gonna pick on me? Absolutely not. There is no problem, right? There is absolutely no problem here. And this here is because I did not terminate it with a semicolon, okay? If I terminate it, there is no problem. I can use fprintf then and say fprintf distance between f1 and p1 and p2 is %4 to f and use \n, and that's the dist. Okay, so I save it as test1 and then I run it. Look, correct? I have 2 points. It gives me the distance between 2 points. Done. I call my M file whatever I want. There is no problem. The way to communicate to script is what? Or work with the script. You have inside the script, you have to type in the inputs, and inside the script, you have to have some way of writing the outputs to the command window. So everything has to happen inside the script, declaring the inputs and displaying the output. And you can name it whatever you want. So how can you work with the script? You simply click run and it runs through it. Now, a function is different. When I want to save a function, first of all, look, this name of the function is suggested by MATLAB when I try to save it as an M file. Look, you see, unlike the other one, it doesn't say Untitled 1 or Untitled 2. The name that it suggests to me is exactly the name of what? The name of that function. So the name of the M file and the name of the function should exactly be the same. If I change it even a little bit, let me change it quite a bit, so call it test2. Well, I want to call this function test2. Look, immediately it picks on you. Hey, this function, my 3D distance is known to MATLAB by test2. You messed up. Because when you want to call this function, okay, when you want to use this function, how do you use it? When you want to use this function, you cannot just click on run. When you click on run, it is going to pick on you and say, hey, you said here P1 and P2. What is P1? What is P2? I have no idea what you're talking about. You cannot run me like that because I don't know P1, I don't know P2. Okay? So you cannot run a function. What you need to do is to call a function, and I'll show you. So, by the way, one more thing here is, look, let me actually first show you how to call a function, and then I'll come back talk about sharing memory. So, how do I use this function? I have to what? Call it. What do I mean by call? It means exactly basically copy and paste the first line, which is function declaration, paste it in the command window, right? Now, P1 and P2 are already defined in the workspace, so it is good. Now, when you want to try to call this function, what happens? When you say, hey, calculate my distance of P1 and T2 and return the answer as this variable dist for me. And for the sake of difference, let me call it dist2 instead of the previous dist. Now, when you call this function, MATLAB goes and looks in its M files for an M file with this name. How does MATLAB find this function? Because your directory can have thousands of M files, thousands of functions and everything. How does MATLAB locate this function that you wrote somewhere so that it can use the code for it? It looks for an M file with the same name. But it cannot find an M file with the same name. Why? Because it is stored as test2, so MATLAB gets confused. Where do you want me to find it? I cannot find any M file called my 3D distance. So that's why you get MATLAB confused, because MATLAB has to look for that M file. When you run something, you don't need to look. You directly use the code here. When you call, MATLAB goes and looks for the source code. So what you need to do is make sure you save it as the actual name of the function. Now this is good, and that test2 that you made, get rid of it. Okay, now this name is good. So now if I call it, right, I just passed to it the 2 inputs from the workspace. Called it, it returns the distance, and that distance is the same as what the script gave me. Right? So I cannot run it. I should, you see, I should call it. I should name it the same name as the function, What else you need to know about a function? Well, let's look at some other things. Even the appearance of the function and a script is different in MATLAB. If you look, the script is simply one, let me see if I can use magnifier. So if you can look here, no, well, it's on the other side. Okay, let's see if I can maximize this or somewhere that I can show you. If it stays here. So here, if you look, when I have a script, the shape of the script is just like the symbol of MATLAB on a piece of paper, while the function is fx on a piece of paper. So even the appearance of them is different. Now, another thing important is when you run a script, any variable that is generated, okay, during the run of the script will be shared in the workspace, will be basically sent to the workspace. But the function is not like that. So here, for the sake of demonstration, I create another variable temp, and this temp is equal to, let's say, whatever you want. Let's say 1, okay? Now, when I call this function, I want to see whether this temporary variable with value of 1 is going to also be saved to the workspace. So here, I'm going to call this again, right? So I clear that distance because that comes from the script. I want to get it from the function. Okay, P1 and P2 I have to have in the workspace or in a script calling this function. Otherwise, function will have no idea where to get P1 and P2. So I need those, fine. It returns the distance to you, fine. Look, what about this temp1? Is this temp of 1, is that also stored to the workspace? No. So if a variable is not an input or an output for a function, anything other than inputs and outputs of the function, if you have temporary auxiliary variables within a function, would they also be stored to the workspace? No. So functions will not share everything they have with the workspace, only what you give them and what they give you back. That's it. Whatever happens in between, as I told you, they do not share. So if there is something here called a temp, right? If there is another variable called z, if there is another variable c, d, f, whatever, none of them will be shared to the workspace. That's why we call this code encapsulation. We makes the code modular and encapsulated. And so now look, just for, again, the sake of knowledge, I do something. I say, look, I bring that here, this temp, and then I say the distance is equal to distance times temp. Okay, so this temp is to magnify the distance, and I use a value of whatever you want, 3 here, or let's go back to 1, fine. So I don't magnify the distance. Good. Now this is what I do. I declare the same variable temp in what? In the workspace, and call it 4, right? Now when I call this function dist again, what do you think the distance is going to be in return? Is that going to be the same as it was, 3.3166, or is that going to be 4 times that number? Right? We changed temp, correct? In the workspace, we are telling MATLAB, hey, temp is 4, temp is not 1. So look, when I call that function, Although I try to change the internal variable temp to another number, look, no change. So it means that this temp and that temp are two different temps for MATLAB. This temp is a variable. They have the same name, but this one, what? This one is in function memory. This one is stored in workspace memory. And a function has its own memory. It is not the same as workspace. So I have two different temps here stored in two different memories. And so that's the other thing I mentioned, avoiding undesirable, unintended bad effects, correct? So if somebody didn't know what's going on inside your function, they declared a variable anywhere in the workspace, in any other script, that had the same name as one of the variables inside your function, are they changing the variable within your function? No. These two are separated, okay? They are independent from each other. And that's the important thing, right? Good. So now that you learned some basics about the function, that's how to use them, how they work, and so on, let's talk a little bit more about them. So what type of functions do we have in MATLAB? Well, the simple function that I wrote for you, that's a user-defined function because I wrote it. There are some built-in functions like what? Like, of course, sine of x, cosine of x, exponential, log, and so on. These are all built-in functions. So when I call and say, hey, what is sine of, let's say, pi over 6, correct? I'm calling this function. And I can get an output and call it whatever you want. A. Okay, so here I'm calling this function sine with value input of pi over 6 and say get the output assigned to variable A. Right, so this is a built-in function. Somebody in math work wrote it for me and I can use that. And if I want to see what's going on inside this, one of the things you used to be able to do is type in edit and then sine. And it opens that M file for the built-in function for you. And you can see what this function is actually doing. So if you look here, this is the sine function, but you don't see any code here. It's just a bunch of comments. Why? Because MATLAB is trying to preserve their especially original functions they wrote, the main original built-in functions they wrote, and so the code is hidden here. You cannot see anything. Okay, now if there are some more higher level functions, sometimes you might be able to see them. For example, let's say sometimes you have a function in a toolbox that is not always available, that toolbox, because of course that's an expensive toolbox, $200, $300. And on one computer you have that toolbox, so you can have access to those functions. On the other computer you don't have that toolbox because you could not afford to have the toolbox on both of them. But you still need one function from that toolbox and you don't have it on this computer. So how would you do it? How would you at least find out how they wrote that function so you can use it? Let's say you are in robotics, okay? And there are some of these important conversion functions to, for example, convert your, let's say, rotation matrix to quaternion, or the quaternion to axis angle representation, and so on. So for that you need to have what? You need to have the robotics toolbox. And let me show you. Here, if I go down, I have the robotics system toolbox. And there are lots of functions here. If you go down to the functions, you can see there are tons of functions here. You can check them here. And one of them, as I said, to convert a DCM, or direction cosine matrix, to, let's see if I can find them for you. modeling simulation, here, coordinate transformation, okay? Let's say you want to convert your rotation matrix to Euler angles, right? So that's this function. You pass through the rotation matrix, rot m to Euler, and it gives you the Euler angles, right? Now, if you want to use this function here in a computer that does not have the robotics toolbox, of course, you cannot do it because it says I cannot find this function. Okay, so one thing you can do is to go and open it, or simply type in edit and then the name of that function, okay, whatever it is, rot m to Euler. That gives you the same thing that you have here. And now if you go and look, if it's not proprietary, then you should be able to see the code, how they are doing it. Sometimes this function is using some other utility functions outside the M file. Most of the time, those utility functions are inside the file. So they are written as nested functions, and we'll talk about that. But you can see the logic behind it, and then you can write something similar to that for your own sake. So here I'm not trying to encourage basically stealing somebody else's code, but I'm just trying to tell you, if you want to understand how each one of these functions is working, then you can open them and see inside them, okay? And then you can write your own code based on the logic. But that's the whole idea. Good, right? So these are the built-in functions. I told you we have scripts, but they are not really functions. Scripts, you run them. We have user-defined functions, just like the one we wrote. And there is another function that is one of my interests, and I found that many times some colleagues do not talk about it too much, and that's anonymous or inline functions. Now, anonymous and inline are not exactly the same thing, but here I just use anonymous. By the way, one more thing I just remembered. When you want to name a function that you wrote yourself, make sure this function, you do not name it. Not only you should not name it with special characters, you know, the name should only be letters, numbers, and underscores, just like variables, okay? That's one, but also do not name them with reserved keywords. So never call something the function epsilon, because epsilon is a keyword, or pi. Also, do not call them with the same name as built-in functions. So do not call this sine. So let's say here you have a function sine, which takes x and returns y as sine of x. Now, you do not want to name it sine. Why? Because sine function already exists in MATLAB. And if you call your own function also sine of x, let's say you want to use a Taylor series, right? So you say, for example, y equals what? X minus x cubed over 6, correct? And then plus x to the 5 over 120. The first three terms of Taylor series, right? This is an approximate sine. Now, again, if you call this sine, then when you say, hey, what is sine of pi over 3, MATLAB will get confused. It doesn't know which one of these signs to use. So before you name a function, search the name you want to give to that function in MATLAB, see if it brings anything. If it doesn't bring anything, then safely use that name. If it does bring a similar name, an identical, not similar, identical name, then change it. So maybe call this my sine of x. Okay, and now you just need to save it as my sine. The same name, of course, for M file and function, and it's not going to pick on you. There will be no confusion, no problem. Okay, so naming functions, you have to be very careful about it. The same for the scripts too. If you have a script, do not call it sine. Okay, you don't want MATLAB to get confused. Now let's talk about this anonymous function, which is another type of function we use. The anonymous function, or the reason we call it inline function is, or anonymous is, when you want to create these functions, you do not save them in an M file. You just create them as a handle, as a variable in the workspace. So you say, for example, f equals, and they all start with at sign of, and then in parentheses, you declare the variable. It has x, or the input. And what's the criterion for the function? Let's say, as I said, x minus x cubed over 3 over 6, plus x to the 5 over 120, and maybe minus x to the 7 divided by factorial of 7. So you see what I did? I defined the criterion of the function in a parentheses. In the parentheses before that, I declared the variable or variables inputs, and everything start with the keyword, with the character at sign. Now, what you're creating here is a variable called the function handle. Okay, and now whenever I want to calculate the value of this function at any point, I just call it the same way I call the sine function, cosine function. So I say, what is f at pi over 6? You see, I simply pass the input to the name of the function and it returns a value to me, right? I can call it anything I want and with as many inputs and any criterion. Now, did I write an M file for it? Did I open a blank M file and wrote function and everything? No. Without even creating an M file, I wrote everything in MATLAB command window line, so that's why we might call it inline. Why do we call it anonymous? Because when you say, hey, MATLAB, find the value of f at pi over 6, there is no M file anywhere in MATLAB files or directories where this f, there is an M file with name f stored. So the only way MATLAB can find f is in its workspace. So you see, although this function exists, but it doesn't have any home for itself, and homes for functions are M files. It does not have an M file of its own. And what's bad about it? The bad thing is this: if anybody comes and clears the workspace, boom, your function is gone. Now, if you say, what is f of pi over 6? MATLAB will say, what are you talking about? What is f? I don't see any f anywhere. Because it didn't have a house, when you clean up the workspace, you have to clean up the guy too. While if it was what? Stored in a function like this, my sign, it doesn't matter when you clean up the workspace and if you do it or not. It always works. You cannot get rid of it unless you delete the M file, but here you can easily get rid of this by cleaning the workspace. So that's why we call it anonymous. And these anonymous are used a lot in when one function is using another function. And we'll talk about it. When you have one function that is using another function, in many applications, you use this, what we call anonymous versions. Like what? Like the command ODE45. Just look at the videos I have for solving dynamics problems with ODE45, and you see that when you're calling ODE45 to solve a differential equation for you, the first thing you call is ODE_fun. So the first thing you say is at my function or something like that. And what you're doing here, you're using the handle of that function and treating it as like an anonymous function. Now, could that my fun be stored in an M file? Sure. But here you're passing the handle of that function to this ODE45. Do you have to store that my function in an M file? No, not necessarily. You can just declare it in the workspace, in the command window. Or when you are minimizing a function or finding the zeros of function with f0, fmin, and so on, you can use these anonymous functions a lot, okay? If you don't want to permanently store them, this is a good way to use these guys. Okay, so I guess I mentioned some of the basics in functions, right? Now let's take it to the next level. So these were just basics. Now let's make it a little bit more advanced. Like what? So when you write a function or a script or anything, one of the most important thing you have to pay attention to is make sure that if the user does not pay attention and gives you a wrong number of inputs or insufficient inputs, you can handle that and just not throw an error all the time, because that will get the people frustrated. So let's say, go back to this my distance. Here, you're supposed to pass 2 points. Okay, you're supposed to pass 2 points, and it gives you what? The distance between the 2 points, right? Now, for the sake of, again, education, instead of passing the 2 points as vectors, let me say you pass the points as their individual components. So you go x1, y1, z1, and then x2, y2, and z2, right? So it has 6 inputs and it returns a distance. Okay? And wait, let me keep this distance here because I want to use something similar to that. So how do you calculate the distance now? It is going to be basically x1 minus x2 squared, right? Plus y1 minus y2 squared, and plus z1 minus z2 squared. That's the square root of the whole thing. Good? So you can write it this way. Now, when I call this function, I'm supposed to give it 6 inputs. What if I don't? What if I only pass to it x1, y1, x2, and y2, and I assume that the points are all on the xy plane, so z's are 0? How would you handle that if I give you only 4 points? Are you going to throw an error? Well, you can. If I don't give you right now enough of inputs, this function will definitely throw an error at me. Look. So I say, what is the distance between point 2, 4? Now look, I don't pass z1. For x2, I pass like -1. For y2, I pass like 6. And I don't pass z2. Correct? So I only pass x1, y1, x2, y2, no z's. Look. Not enough input arguments. I wanted 6, you gave me 4. Could you handle that? Yes. The thing that I can do is check how many inputs the person is giving me. And if they are not sufficient, maybe I can do some assumptions, use some assumptions, and assume some values for them. Now, how can I check how many inputs the user has given me before I do any calculations? The way to go about it is the command called nargin, the number of input arguments. Okay, this function, this built-in function, will return how many inputs the user has used to call your function. So you say something like this: if nargin, if the number of input arguments is what? Is equal to 4, then you assume z1 is equal to 0 and also z2 equals 0 end. And then calculate distance. Now look, if I do the same thing I did last time that gave me error, this time, let's see. Okay. That's the other thing I have to do is not only set z1 and z2, I have to tell it which one is which. because it gave me 4 inputs, but I have to tell it these 4 inputs now are what? Which one of them is x1, which one of them is y1, and so on. Because the order is not observed, so I have to tell it. So I have to say, if that happens, then your x1 is going to be the first input. Now, how do I get the first input? That's where you have to use the other built-in function in MATLAB, and that is called what? That is called variable argin. So not because with variable argin, you're allowing this input to be variable numbers. Right now it's rigid at 6. You cannot even go with 4. Even if you say if it didn't enter Z1 and Z2, you assume something. This declaration does not allow for any flexibility. It always expects 6. Regardless of what you do here, it is going to pick on you. But if instead of all of this, you say what? Varargin. What does this mean? It means you have a variable number of input arguments. It could be 6, it could be 4, it could be 2, or whatever. Now, all of your inputs, whatever you enter, all of them will be stored in this single variable varargin. And this varargin is a cell array. It's not a regular matrix. So when you want to access its first or second or third component, you should not say varargin number 1. Since it's a cell array, you have to use braces instead of what? Instead of parentheses. Now you say whatever they entered, the first one I wanted to call x1. Then what? The second one I would call it y1. Z1 I assume it's 0, and then what? The third one and the fourth one are going to be my x2 and y2. And Z2, I just assume it's 0 as well. So now you're allowing for flexibility. You get the components out of it. You assume the missing ones, and now you calculate the distance. So now look what happens. Now if I call it with 4, is that going to work? Yes. You see? It assumes the 2 missing ones are Z1 and Z2, and they are 0. So if you want to be able to handle inappropriate inputs or insufficient inputs, you use variable argin, and what? You use nargin to check. So you might add one more thing. What if they entered only 2 inputs? Then you might say, maybe I call them x1 and x2, the rest of them y1, z1, y2, z2, they're all 0. Fine. What if they entered 5 inputs? Do I want to throw an error, or I just say the first 3 are x1, y1, z1, the next 2 are x2, y2, z2, 0? How do you want to handle that? And that's what you see in many built-in MATLAB functions. Before they declare the actual criterion for the function, they have lots of these ifs and nargin in the beginning to handle errors. Okay, let me show you one other of those cases. That was that robotics toolbox code. So you see here, it's supposed to give you the matrix, and look here, you have variable argin. It allows the second argument to be variable number of inputs. You have to give it the rotation matrix, no flexibility on that. But after that, you can give it some options. What are these options? Here it tells you what kind of Euler angle you want and so on. So the second option is variable, and you see here that it should have some nargin somewhere. Let's see if it has something like that here. If it doesn't, I can find you other functions, but you clearly see variable argin here. Not all of them do have that, but many of them do. So maybe let's see the command edge that detects edges in an image, right? You see, it can get variable number of input arguments, and then there are so many checks here for whether they have entered, you see, the proper names and everything like that. Okay, so here it is using string compare and so on and so forth. If is empty and so on. All of this that you see here are all error handling. You see how much of it is error handling? Then after some time, now you start to do the edge detection. Okay, so there are tons and tons of code that you see, lines and lines of code in the beginning of built-in MATLAB functions that are just for handling erroneous inputs or insufficient inputs or so on. Okay, so this varargin, nargin, and so on, these are very useful things. Similarly, for outputs, we have something similar, nargout and variable argout. So sometimes maybe your function can return 2, 3, or so many outputs. Let's say this function, not only it returns the distance, it also returns the dot product. Of those 2 points. Now let's see here. The function return value might be unset. Of course, yeah, I haven't defined it yet. But it gives you 2 outputs, correct? And this output, inner product, is equal to the dot of vector x1, y1, z1, and vector x2, y2, and z2. Okay? So I call it test2, and I save it as test2. The question is this: if I call this function and do not ask for 2 outputs, just ask for 1 output, is that going to throw an error at me and get upset, or it just returns something? So let's call this function, right? And I'm not going to ask for 2 outputs. Maybe I just ask for 1 output A. And let's see what happens. You see, it did not throw an error at me. Last time, when I did not handle the insufficient number of inputs, it expected 6 inputs, I gave it 4, it threw that error. Now, when I do not ask for both outputs, it gives me 1 output, but the question is, which one is this? Which one is that? Okay, is that the distance or is that the inner product? I have no idea, right? I can check. Is that the inner product? So this is x1, y1, x2, y2. If we multiply, that is 4, that is -2, so that's 2. So the inner product is 2, so that should be the distance, I assume, right? That's 3 squared plus 5 squared, correct? That's the square root of 9 plus 25, which is 34, correct? Or let's make sure. Let me make sure. 2 minus 1, that's 3. Oh, 1 minus 4, that's -3. So 9, 9, 18. Right. So it only returned the first output. The second output, of course, you didn't ask for it, didn't give you. If you ask for both of them, it would give you both of them, of course. Right? But when you didn't ask, it didn't get upset and it didn't throw an error. So that's a separate thing. But here you can make it a little bit more organized and say, hey, maybe I want to say this is variable argout also. This is a variable argument out, right? So you calculate distance and inner product, and then you say, if nargout. If the number of output arguments they ask from you is equal to 1, then varargout number 1 is equal to dist. Okay, or simply it's equal to dist. Or just the first one equal to dist. Else if, correct, nargout equals 2, they ask for both of them. Now you need to tell it in order that the first one is this, the second one is what? The inner product. And else, which means if they ask for more than 2 outputs or less than 1 output, then you definitely want to give them an error message. Error, wrong number of outputs, end. Okay, so this way you can handle that. You can handle nargout. Most of the time, you mostly handle inputs than outputs, but this is how you handle the outputs as well, so you know which one is going to be passed. But MATLAB default is always it starts from the left output and goes toward the right output, depending on how many of them you're asking. So if you ask only for 1, it's going to be the leftmost output you declared. If you ask for 2, it's going to be the first one and second one from the left, and so on and so forth. But you can handle that if you want like this as well. So anyways, this is how you handle the variable number of inputs and outputs and allow for flexibility in the number of inputs and outputs using variable argin and variable argout, nargin and nargout. Okay, so that's one of the important things that I wanted to talk about. And the commands warning and error that you know from the past. Now, what else? Another thing you need to know about the functions is local functions and nested functions. Okay? These are also important. These are higher level things that you need to know about functions. What is that? So, what is a local or a utility function? So let's say you write a code, a function, that when you pass through it a vector, it returns to you the range of outliers. If you know from statistics, one of the simplest methods of determining the outliers is what we call the box method. And it says 1.5 times interquartile range from Q1 and Q3, less than Q1, bigger than Q3. Any number outside that range is what we call an outlier. So let me tell you what I mean, because maybe you don't know about it. So it's called box method for outlier detection. And all you need to do is to find the first quartile and the third quartile of your data. If you sort it from lowest to highest, call them Q1 and Q3. The difference between Q3 and Q1 is what we call interquartile range, IQR. And then any number that is less than Q1 minus 1.5 times IQR and bigger than Q3 plus 1.5 times IQR is considered an outlier. So you can see that here. Okay, this method is called the box method. And this is very common when you want to detect outliers and keep them away from statistical analysis. So the code I want to write here for you gives you those two numbers, Q1 minus 1.5 IQR, Q3 plus 1.5 IQR. If you give me a vector, I determine those, and give them back to you so that you can determine which numbers in that vector are outliers. Or maybe you just give me what? The vector, I give you the outliers. That's even better. So I say outliers is equal to my box method of some input array, and maybe I call it just vector x. Okay? Now, don't use semicolon here, and then end. Okay, so this is my main function. Now, this main function is like a main contractor. You give the whole job of finding outlier to this main function. But this main function, like many constructors, is using some subcontractors to do the smaller jobs for it. So it is using them to do the bigger job. It's not doing all the job by itself in one step. It is dividing the job and what? Concurring, right? Divide and concur. So it breaks down the big job into smaller jobs. Each one of those smaller jobs is done by another function we call a utility or local function. So this is your primary or major function, and then you have some utility functions. So here, when this guy is called, this is what it does to vector x. What it does, it calls another function. That function will return to this guy the two limits, lower limit and higher limit. So this one says, hey, the lower limit and the higher limit is equal to another function that is called box, and you pass to it vector x. When I get those limits, then I say x. I create an outlier first and say outlier is equal to empty brackets. I started empty, and then say outlier is equal to whatever it is concatenated with those in x where they are what? Less than the lower limit. And also those in x that are what? Higher than the higher limit. Done. So I find the outliers here and add them. Or if you want, you don't even need to do that. You can just say something like this. You can avoid this initialization. You can just go like that. Done. Now the question is, how do I find these two numbers using this utility function box? Now this utility function box, how do you define that? Can you define it within this function, or it has to be outside this function? Well, if it's a utility function, when you want to use it, you declare it outside the main function as its own independent entity. Okay, so you define it as its own entity, as its own function outside this function. That function gives you what? As I said, the higher and lower limits. Now, how do you use that function? This is what you do. You say the lower limit is equal to PRCTL, if I'm not mistaken. It's the percentile component, command in MATLAB. PRCTile. It's called PRCTile of x. Okay, and you have to pass to it the number. Okay, so this gives you the so much percentile of some vector x. So you pass to it vector x and p, where p is between 0 to 100. So q1, if you want, I can do this. q1 is the 25th percentile of x. q3 is the 75 percentile in x, interquartile range is equal to Q3 minus Q1. Now the lower limit equals Q1 minus 1.5 times IQ range, and higher limit is equal to Q3 plus 1.5 IQ range, and that's it. Okay, by the way, there is a command in MATLAB called IQR, which if you pass to it vector x, it directly gives you this number, which basically that does the same job as finding Q1 and Q3 and subtracting. So you see here, I can write above it, this is my utility function or local function. That guy up there is my primary function. Okay, so I can write it somewhere for you. So, and I save it. What do I save it? Which one? The name of which function will be used for the M file? Of course, the big guy. Everybody knows the big guys, right? Nobody knows the subcontractors. Everybody knows, hey, this project was done by my box method. Nobody says, well, maybe the biggest job was actually done by this box function, not by the main one, but this is the person everybody knows. That's the big guy. So we save it with that name. And now let's call the big guy. We pass to it vector x, call the big guy, and say, hey, you give me the outliers. So let's do it. So here I call it, and I pass to it some vector x, and I try to make some outliers. So let's say 1, 8, 9, 10, 12, 14, 38, something like that. Okay, let's see. If I pass to it, okay, first of all, it is not happy. Why? Because this is outlier, that is outliers. So make sure that your naming is correct. And it says the only outlier here is 38. The rest of them are good. Now, if you made this one probably a little bit smaller, like negative 10, that would probably also be an outlier. Yes. Okay. You see? This function is called, it says, well, I need to find where this is happening, but I need these limits, and I use this utility to do that for me. How did I define the primary and utility? The primary is a function that should end with keyword end. The utility also is a keyword that should end with keyword end. They are two separate things, but since this guy is below the top guy, right, it can access the result of that. So this is about utility functions. Now, what about access to the variables? That's another important thing that I want to talk about. So let's do something, again, for the sake of knowledge. If I declare a variable here like temp equal to, in this function, can I use this temp declared in this utility? Say, hey, outliers are whatever they were, but plus temp, I'm sorry. So I'm trying to access a variable. I'm trying to access one of the workers in this subcontractor and ask that worker to come and help with the end result. Not only I'm asking this entire subcontractor entity, I'm also trying to access one of its individual workers. Can I do that? Let's find out. No. So the subcontractor says, hey, you did everything into your own name, you used everything for your own sake, everybody knows you, you are doing everything. The least thing you can do is to not go behind my back and also try to separately work with one of my workers. I'm not going to allow you to access that. So the primary function cannot access variables in the utility function. What about backwards? Can I here say this is equal to this plus temp and this plus temp. And temp, I define it in the primary function. Can I do that? Can the utility access variables in the primary? Well, let's try that. No. You see? The utility cannot access the variable in the primary function as well. Why? Because each one of them ended with the keyword end, so they are encapsulated. They are separate from each other. They can pass their inputs and outputs, but not the interior variables. Okay? They are two separate entities, independent, encapsulated. So that's very important. They cannot share any of each other's variable. That's the important thing. Now you might say, well, what if I really want to be able to share some variables between them? What's the way that I can do it? And the way to do it is either you write the whole thing as a script, not as a function. If you write the whole thing as a script, okay, then this function can use the variable in the script. The script can never use the variable in the function. But the function can access the variable in the script. So one way I could write it is something like this. Look. I create vector x. I get these lower and higher limits from this utility function, and then I create the outliers. And I write it as a what? As a script, not as a function. Now, if I declare this variable temp here in the main script, can this utility function use the variable in the script? Let's find out. So first, let's create this vector x, just like last time. Right? Now let's see. This utility function can work for the main script and also uses the variables in it. So here I'm going to save this as test3, and I'm going to run this test3. Unrecognized function or variable temp, right? So here, when this guy wants to use this temp, it could not use it. It could not. So, but you just said it could, right? But it doesn't. It does not. So there is, yes, it can, but you have to do one extra thing to make it happen. And that's now the new topic I have to talk about, global variables. So it can access this variable in this script if this variable is a global variable. Right now, it's only in the workspace. This is has its own memory. There is no connection. But one of the things you can do is to go with what? With a global variable definition. So what you need to do for the global variable is this. First, you declare the variable as global. You say global. And then you declare the variable, temp. Then you define the value for that variable. So please pay attention to this part. When you declare a variable as global, which means everybody can have access to it, whether function or script or something, the declaration of that variable being global is done in one line. The assignment of that variable is done in a separate line. You cannot do both of them at the same line, in the same line. It's going to pick on you. By the way, when a variable is global, the color of it, instead of black, it goes to green. Okay? Now that I declare this as global, can this function use it? Not yet. Inside this function, you still have to come and say, hey, this temp that you are trying to use here, that's the same as what? That global variable that the main script talked about and introduced. Now, look, the color goes green in the function as well. Now the function has some idea that, hey, this is the same global in the script. Now can I use it? So look here. Oh, I have to just run it here. Boom. Right? You see? I can easily run it now without any problem. So if you want to share a variable from a script in a utility function, you have to declare that variable as global. Okay? That's one way to do it. Another way, if you want to do some sharing between these functions, is to use what we call nested functions. What is nested function? So maybe you don't want to write your code as a script. Here I had to write it as a script, and you know scripts have problems, correct? Although this variable is global, if somebody in some other code comes and tries to change temp2, they can, because it's a global variable and everybody can have access to it. And that's the problem with global variable. They are not safe. Anybody else in their code, if they use the same name and change the variable from 2 to something else, they can change this variable and mess up the whole calculations. So that's why people prefer functions, because they are safe. The variables within them are safe from other scripts and other functions. So the nested function, what it does is this. This is the utility function this guy is using, but instead of declaring and creating it as a separate entity outside its body, it creates this guy and use it and define it within its body. And so you have to indent it 1 unit forward. You see what's going on? I'm using it, but I have defined this guy within the body of the main function, okay? Now, these guys, we call them what? We call them nested functions now. And the primary function we call the host function. Now, the question is this. Can this nested function uses a variable declared in the host function? So can I declare this temp here and use it in the nested function? Well, as you can see, now they all match the same color, and the color goes green, just like a global variable. So you will be under the impression that now, yes, the nested function can have access to the host function. It doesn't go backwards. Still, if you declare a variable within the nested function, you cannot use it in the host function. But the opposite direction, can nested use the variable in the host function? It seems like, yes, it is possible, because they look like global variables now. They are green. They all have the same color. So you say, well, let's run it and find out if it can do it or not. So here, look, I do it and boom. Although I expected it to work, it doesn't. Still says, what are you talking about, temp? I don't see temp. I cannot recognize it. And you say, well, it seems like you could. Why are you talking still like I cannot find temp? Well, here is the subtle thing. Yes, this temp is recognized. The problem is when you call this nested function in line 2, after you called the box in line 2, then in line 4 you came and declared the variable it needs. So if you want to declare this temp, you have to do it before calling the nested function. That's the important thing. The order matters here. You go from top to bottom. You have to first declare the variable it needs, then call it. Otherwise, it cannot access it. Now look here. Okay? So again, summarize it. The nested function can use the variables declared in the host function as long as they are defined before calling the nested function. Okay, so that's about nested functions, about nested function and host function, about primary and utility functions, about global variables, and so on and so forth. Now, for the last thing I want to talk about passing a function to another function as a handle. Okay, because that's one of the more advanced topics and I feel like I need to talk about it. So let's talk about that one. And then with a few small remarks, we should be able to finish this important lecture. So let's say here you have a function, and this function will calculate for you the radius of curvature of a function at a specific location. So you pass to it the function, you pass to it the location. This function will give you the radius of curvature of the function at the location. And as you know from your calculus knowledge, the radius of curvature is a function of the location. If y is, for example, a function of x, then the radius of curvature at location x naught is equal to 1 plus f prime, the first derivative, squared the whole thing to the 3/2 divided by magnitude of f double prime. This whole function of x is evaluated at what? At x equal x naught. So in order to calculate this radius of curvature, I need the function and I need the location to return this one. Right? Now, how do I do that? So I write the function, I say function rho equals radius of curvature for f and x naught. Right? And then here I need to calculate the derivatives of f prime and f double prime, evaluate them based on that function in x naught. And now the question is, how do you pass a function to another function? Correct? Because this f is not a number I can pass to this function. It is the handle of another function. So for example, this f, I can declare it in the workspace or in another script and say this f equals at sine x of, let's say, 1 plus x to the 4. And then x naught is equal 2. Correct? Now, when I call this radius of curvature function, pass to it this f and that x naught, can I, first of all, take the derivative of a function that is defined as an anonymous function? Can I? Because you know, if f was declared as a symbolic function, when f was declared as a symbolic function, could I pass it to this function? But taking derivative of that was not a big problem, right? For example, if you said sims of x, then g equals 1 plus x to the 4, right? Now I can easily say diff of g and x and 1, correct? Now you have the first derivative, you can do this, the second derivative, and then use the command eval, right? Say eval the answer. But first you have to, before that, set x equal to x naught, and then say eval the answer, and it evaluates that 12x squared at x of not of 2, so it's 48. Right? And you can do the same thing for the first derivative and then plug it into that formula. So evaluating the derivatives of a symbolic function is easy. Use the command diff and eval. But what about an anonymous function? Can you take derivative of an anonymous function? Or should we even do that? I mean, if we do with symbolic, can I pass it? Can I pass a symbolic function to what? To another function. Instead of a anonymous, can I pass f here? Well, let's find out. So first we try symbolic. We define f symbolic, or g, or whatever you want, and try to pass it to here. So this is what I do. Clear CLC. First I create x as a symbolic variable, and then f is 1 plus x to the 4, and x naught is 2. Good. Now I will pass f and x naught to this function when what it does is it calculates the derivatives. So first it says f prime is equal to diff of f and x and 1, and then f double prime is equal to diff of f and x and 2. Now set x to be equal to x naught, and then the value of f prime at x naught is equal to eval of fp. Let me bring them all closer to each other so you can see it better. And then the value of f double prime at x naught is evaluate fpp. And now the radius of curvature is equal to 1 plus f prime at x naught squared, the whole thing to the power 1.5 or 3 over 2, then divided by absolute value of f double prime at x naught. Correct. So that's that formula. Can I do that? Well, let's find out. So here I save it as radius of curvature. I call it with the f and x naught that I declared in the workspace, and I see if I can do it. And boom, I get the error. Why? Because here I'm talking about x, but this function does not have access to the symbolic variable. Although it is defined in the workspace, but it does not work with it. So if you want to use it, you have to here declare that x to be symbolic x. If it was a number x, it wouldn't have any problem. And you pass it to it. But here, this x, I declare it symbolic now. And now let's see what happens. There we go. Now it is working. Now that it knows x is symbolic x, not number x, it can calculate the derivatives. Yes, now you can pass this symbolic function f to it, do everything, and guess what? Now you can easily calculate radius of curvature. So you see, if I want to pass a function as a symbolic function to another function, no problem. I can easily do that. Now what if I define this f as what? As an anonymous function. Can I still pass it to this other function? Okay, and the problem is, yeah, I can pass it probably, but can I take derivative of that? So that's where you need to do a search, right? You need to see whether you can take derivative of an anonymous function. So without defining it yourself. So here, I'm just again showing you whenever you don't know something, take a look at it, look it up, right? So taking derivative of an anonymous function in MATLAB. Can I do that? Okay, derivative of a function handle, basically. That's what it is. Can I do that? So here, that's my f. And it says to take derivative of a symbolic function, you need to create a function handle. Well, we know that one, right? We know symbolic. There is no problem with symbolic. But if I want to take derivative of an anonymous function, look here, clear all CLC. Let me declare f as an anonymous function again. Can I now say diff of f and x and 1? Now, it does not know what you're talking about x. It does not know x. What if you simply say diff of f and 1? No. It says what? It's the incorrect class. Can I use x with quotation mark? No. So you see, the diff command is a symbolic command. If you have doubt about it, go and check it out. See if you can get to work with diff symbolic. Differentiate symbolic. So you cannot, that's the answer, you cannot take derivatives of an anonymous function, of a function handle. You can only do it to symbolic. And so for the sake of this example, the only way is to go by symbolic functions. But good, that's because I'm using a symbolic toolbox function and I have to go symbolic all. But if I declare something like this f and as an anonymous function, can I pass the handle of this function to some other function? The answer is yes. As long as you are not using the symbolic toolbox commands, you should be fine. So for example, let's write another function. And here I pass to it that f, and let's say I want to, what? Just take that f and evaluate it over some range and return some minimum, correct? And let's say that range is determined by two numbers a and b, and it returns the minimum value. So my function is min value is equal to my min of, now what you need to pass to it is f and what? A and b, the two ends of the range. So what this function does, it calculates the f values. This is equal to value of f in a range of x between a to b, let's say linear space, and a to b, and maybe 1,000 points. And then f value is equal to f evaluated at x, and finally the min value is equal to min of f values. Right? So very simple. I define a range a to b, generate x vector, calculate all of the function at all of those x values, find the minimum and return it. So this is my own version of a minimum. And here I call it my min. This is my function at sine x 1 plus x to the 4, and I want to find the value. Now maybe I make it a little bit more interesting because this function is strictly increasing function. So maybe I say something like negative x cubed, and then 2 minus that, and then plus x to the 4 and minus 0.2 times x to the 5. So let's make it a little bit more interesting, and maybe even I add some other terms, but that should be good enough. Now, one thing is this: since you are evaluating this function f at a vector, not at a single number, you need to make sure when you declare this function f, you allow for the power of a vector. you need to make sure each element in the vector can be raised to some power. So you need to use what? Dot power. If you don't use dot power and here you try to raise the whole vector to the power 4 or 5, you're gonna face errors. Make sure you write your function in a way that it can handle scalars and vector inputs. So write it this way. Now I want to pass this f and a range of a and b. Let's say a is -2 and b is 3. In the range of a to b, I want to find the minimum of this function. So what do? I call the function and I have a and b. Now when I want to pass f, since it's an anonymous function, I say at sign f. Okay, I'm telling it it's a function handle, I'm giving it to you. And boom, you get an error. So what are you talking about? What is f? Undefined function or variable f, right? Here, you see? So here I have some problem. It doesn't like it. If I say it is what? It was really a function handle. Now what? Now it even is less happy. It says, hey, invalid use of operator f. You see? So it does not like it the way it is. Now what is missing here? And that's one of the reasons I'm not editing. I want to show you all sorts of errors that can happen when you're dealing with this type of problems. When you pass a function handle to another one, why is it that I'm getting an error? Although it seems like everything is clear, right? F is already defined as a function handle. So maybe I should not even pass it with any handle. How about that? There we go. When it is a function handle, it already has @ sign. When you pass it to another one, you do not do @ sign. This is different from when you used OD45 and used @ sign for it. When you use @ sign in a function, that function was already declared in an M file. But here, you see, it is already a function handle. No @ sign is needed. Just pass it directly to it. Don't use @ sign here. Don't use @ sign in the declaration of the accepting function. You are good. Okay? So this is another important thing I wanted you to know. The very last thing I want to talk about is called persistent variable. So far we have seen local variables, right? The function variables, they are local, right, to themselves. And global variables that almost everybody can access. And then now there is one last type of variable I want to tell you about, and that guy is called persistent variable. What is persistent? Let me show you that one. Okay, to demonstrate the use and meaning of this persistent variable, I need to use a GUI. So I typed in guide to bring me the GUI creator, and I started with the blank GUI. And to that GUI, I added a push button and a static text. And all I want to do is this: keep pushing on this push button, keep clicking on it, and this guy on the right side shows me how many times I have clicked on this, right? So that's all it is. Keep track of how many times I have clicked on this push button. A simple task, right? Which you will use in many different applications. You want to keep record of how many times you have done some task. Good. Now, here I'm going to save it as a persistent variable demo. Right? That's what my GUI is, and this is the function behind the scene that is doing everything. If you don't know about GUIs, please watch the 2 videos I have published on graphical user interface, or GUI. So what is it happening here? When I run this guy, I get this GUI. And when I click here, you see, of course, right now nothing is happening, because when I do this push button, in the function for the push button, I have to keep track of how many times I have clicked on it and then show it on this static text. So first thing is I have to come here in this push button callback and I add what? I try to find out how many times I'm calling this guy. I have to see how many times I'm calling this guy. And when I find how many times I'm calling this guy, I show it on the static text. Correct? So I have to say set, and then I have to say handles dot, and I have to look at the name of this guy. The tag for it is called text2. So set handles text2, correct? And string, and then num to string of some variable like n, where n is the number of times I have clicked on this guy. Now here, I say n, I started with 0, and then each time you call this function, it is going to add 1 to the n. And by the way, I just made the mistake. You should not put this handles.text2 in the quotation mark, okay? So this code is supposed to keep adding 1 to n every time you click on the push button and then show the result on what? On this static text text2. So let's run it and keep pushing. So look, it went to 1, but now regardless of how many times I'm clicking, it is going to stay at 1. It is not going to go up. Why? Because anytime you call this function, n will be set at 0 first, then add 1 to it, so it becomes 1, and it shows it. Next time you call it, again, n is going to be set at 0 and will go to 1. So you might say, well, maybe I don't even start n at 0. Let's just n handle it, be handled at, just be added 1 at a time and no setting at 0. That's the problem, that you set it at 0 each time. Well, what do you think is the problem now? I'll tell you what. Well, the problem is when you're talking about n, here in line 83, and say, hey, add 1 to n, it is going to ask you, what is n? You have not declared n. Look. Boom. So n, you have some problem with n. You have to declare it somehow, set it to some number, and add to it every time. But next time you call it, you want to keep its current value and not going back to 0 again. Okay, so you want to keep the value of a variable by calling a function over and over and not resetting it or not setting it to the same number every time. And this is not possible with regular variables, because these regular variables are only generated whenever the function is called. And when you call them anew, they are created from scratch again at the initial value, and you start from scratch. That's why that number never goes up from 1. So is there a way that when you call it first time, you set it at 0 and increment it to 1, but next time you don't start from 0 again and just go to 2 and so on? Yes. The way to go about it, as I said, for this value of n to keep its value from one call of the function to another, is to call it persistent. First of all, you have to call this variable n a persistent variable. The color of it is going green. And then doing this, you say if is empty of n, if this variable n is empty, which means it has not been set up yet, if this variable is empty, correct, then set it to what? set it to 0. If it's not empty, something has been assigned to it, then what? Then just keep adding. You see, so only if nothing has been assigned to it, set it to 0. Otherwise, just keep incrementing by 1. And retain its value. It's a persistent variable. Now look what happens. 1, 2, 3, 4, 5, 6, 7. Correct? So that's how to go about retaining the value of a variable created inside the function over several calling of the function, is to use it as a persistent variable. Okay, so now with all that saying, I hope I have given you enough information on how to create functions, how to use them along with other functions, other scripts, and so on, how to create global variables, local variables, what is the scope of each variable, whether it's accessible to other functions or not, nested functions, so on. And maybe one last thing is, if you write a script, can this script use the function in another M file? Absolutely. Right? So look, this mySign function is created and saved in a separate M file. Now, in a separate script, can I call that function? For sure. So I'm calling a function that is written in a separate M file in this script. I don't need to bring this guy as a utility and put it down here. I can still call this function in the other M file within this script with one condition. So here, test4. Look, can I run it? Sure, no problem. It doesn't need to be in the same M file. Look, you see, working fine. There is one limitation though, and the last thing I have to say, this limitation is when you call a function in another M file, in a script or in another function, you need to make sure both of them are in the same folder, or both of them are under MATLAB search directory. They are both under here, the set path. If they are not in the same folder, then you cannot do it. So for example here, if I go and cut this mySign function and take it to another folder, right now it is under downloads, but now look, I go and find this mySign function and cut it and take it to desktop. Okay, not mySign function, of course. Where is that here? So look, now it is not in the same folder, right? Now look, I run it again. Wait, clear all. Not sure if it's completely gone. Yes, now it is good. Now look, here. Well, what happened? You just told me it's not going to work. In this case, it does. Why? Because desktop, I have added desktop to my search path of MATLAB. If you go and look here under my MATLAB path, desktop is one of them. So although they are in two separate locations, one in desktop, one in downloads, because desktop is added to where if it cannot find it under downloads, it goes and look at the rest of the folders here. And one of them is desktop. Now, if I get desktop off here, look, let me remove it. So now desktop is not accessible to everything else. Now look. Boom. Now I don't recognize this function anymore. I cannot look it up. It's not in the current folder. It's not in those shared folders I can find here. So either bring that my scene back to here under downloads, or wherever it is, which is desktop, go ahead and add that desktop to the list of what I can look for and save it. Now it doesn't matter if it's in the same folder or not. I should be able to do the job. Okay, so these are very important. Okay, thank you so much for your attention. That's called sharing of workspace. Thank you so much. I will see you in the next lecture.